Hello guys, welcome to another video here on the pre-security part, and we've currently covered the introduction to cybersecurity. We've covered the network fundamentals, and we're currently on how the web works. The last video was on DNS in detail, and today we're covering HTTP in detail. Now without further ado, let's get started. Now over here we're starting the HTTP in detail, and over here we'll have a lab, and then there's a walkthrough video which we're going to skip, and let's dive into task 1. What is HTTP or HTTPS? Now, what is HTTP? The meaning is hypertext transfer protocol. Now, the HTTP is what's used whenever you view a website. It was developed by Tim Berners-Lee and his team between 1989 and 1991. Now, the HTTP is the set of rules used for communicating with web servers for the transmitting of web page data, whether that is HTML or images or videos, etc. Now, what is HTTPS? Now, that's like the secure version. So the HTTPS is the hypertext transfer protocol secure. Now, HTTPS is the secure version of HTTP. Now, the HTTPS data is encrypted, so it not only stops people from seeing the data you are receiving and sending, but it also gives you assurance that you are talking to the correct web server and not something impersonating it. All right, let's dive in here. So over here on the lab, okay, we'll get to that. What does the HTTP stand for? We have the hypertext transfer protocol. Correct. Now, what does the S in HTTPS stand for? That should be secure. And on the mock web page on the right hand side, there's an issue. Once you've found it, click on it. What is the challenge flag? Now, over here we have Tryhackme. Welcome to Tryhackme. This is the website, but if you notice, there's really HTTP and it's not locked. So basically that might be the issue. And as you can see, you got the flag. So it needs to be like HTTPS to make the website secured. That being said, we have our flag, and that's correct. Let's head on to task 2, requests and responses. All right, when we access a website, your browser will need to make requests to a web server for assets such as HTML, images, and download the responses. Now, before that, you need to tell the browser specifically how and where to access these resources. This is where the URLs will help. Now, what is a URL? It means Uniform Resource Locator. The Uniform Resource Locator. Okay. Now, if you've used the internet, you will have used a URL before. A URL is predominantly an instruction on how to access a resource on the internet. Now, the below image shows what a URL looks like with all its features. It does not use all features in every request. All right. So we have scheme. Now, the scheme this instructs on what protocol to use for accessing the resource, such as HTTPS, FTP, which is the file transfer protocol. So the first one, which is the scheme, specifies the protocol. Now the next is the user. All right, some services require authentication to log in. You can put a username and password into the URL to log in. So it's more like the user, and then the password will be on the user part. Now, the host, the domain name or IP address of the server you wish to access. So you either have the domain name of the host, basically what that means, and then if you're using more like the IP address, you have the IP address and the port, which is what you see here. Oh, sorry, port is the next. I'm sorry. All right, now the host is the domain name or the IP address. Now the port is the port that you're going to connect to, usually 80 for HTTP and 443 for HTTPS, but this can be hosted on any ports between 1 to 65535. Okay, so you can pick the ports open, or the port that can be used is between 1 to 65535. Okay, The next is the path. Okay, now the path, the file name or location of the resource you're trying to access. So you're trying to access the view room path, for example, from here. Now the next is the query string. You need to extract bits of information that can be sent to the requested path. For example, /blog question ID equals to 1 will tell the blog path that you wish to receive the blog article with the ID of 1. So more like what you see, ID equals to 1 here is more like what you want to access in this view room. And lastly, the fragment. This is a reference to a location on the actual page. This is commonly used for pages with long content and can have a certain part of the page directly linked to it, so it is viewable to the user as soon as they access the page. Okay, now making a request. We just covered the whole URL. Okay, making a request. It is possible to make a request to a web server with just one line: get/http/1.1. Now, but for a much richer web experience, you will need to send other data as well. This other data is sent in what is called headers, where headers contain extra information to give the web server you're communicating with. But we will go more into this in the header tags. Okay. Example of a request, so more like the request method, the HTTP protocol version. This is just what makes up the request, and then the page being requested in total. All right. Now, example of a request. Now we have the get HTTP /1.1. The host is tryhackme.com. The user agent will get. Let's break it down. To break down each line of this request, we have line 1. The request is sending the get method. More on this in the HTTP methods tags. We'll get to that. Request the home page with / and telling the web server we are using the HTTP protocol version 1.1. That's what this means. Now line 2, which is the host, we will tell the web server we want the website tryhackme.com. Okay. Now, line 3 will tell the web server we are using the Firefox version 87 browser. That's what this means. Mozilla /5.0 Firefox /87.0. Okay. Now, line 4, we are telling the web server that the web page that referred us to this one is https://tryhackme.com. Okay, makes sense. Now, finally, line 5. We have HTTP request always ends with a blank line to inform the web server that the request has finished. Okay. Example response HTTP /1.1. This is not example of a response. This is example of a request. So the response will look like this. Now let's start with the breakdown. So we have the one is to line 1, HTTP 1.1 is the version of the HTTP protocol the server is using, and then followed by the HTTP status code, in this case 200K, which tells us the request has completed successfully. All right. Now line 2, this tells us the web server software, and version. So this is the web server software, and this is the version. And line 3 tells us the current date, the time, and the time zone of the web server. Line 4 tells us the content type header. It tells us the client that's the client what sort of information is going to be sent. It tells the client what sort of information is going to be sent, such as the HTML, images, videos, PDF, XML. So here we have text and HTML. And then line 5 is the content length. It tells us it tells the client how long the response is. This way we can confirm no data is missing. Okay. Line 6 is the HTTPS response. Contains a blank line to confirm the end of the HTTP response, which is here. And then line 7 to 14, which is the whole of this, the information that has been requested, in this instance the home page. All right, let's move on to answer the questions we have here. What HTTP protocol is being used in the above example, we've been using the HTTP /1.1. Sorry, it should be a slash. Correct. Now, what response header tells the browser how much data to expect? That should be the content length. Okay, content length. Correct. Now we're done with task 2. Let's head on to task 3, HTTP methods. Now HTTP methods are a way for the client to show their intended action when making an HTTP request. Now there are lots of HTTP methods, but we'll cover the most common ones, although mostly you will deal with the get and post method. All right, now the get request. This is used for getting information from a web server. The post request, this is used for submitting data to the web server and potentially creating new records. Okay, that's the post. Now what's the put? The put request, this is used for submitting data to a web server to update information. That's the clear difference between the post and the put. They're both submitting data into the web server, but one is to create new records, one is basically to update information. That's post and put. Now delete request, this is used for deleting information /records from a web server. Right, that's quite simple. Now let's answer the task questions here. What method would be used to create new user account? That's post. And what method would be used to update your email? That should be put. And what method would be used to remove a picture you've uploaded into your account? That is a delete request. Now, what method would be used to view a news article? That should be get. That's that for the end of the HTTP methods. On task 4, let's look at the HTTP status codes. Now, in the previous task, you've learned that when a HTTP server responds, the first line always contains. Let me open this. The first line always contains a status code informing the client of the outcome of their request and also potentially how to handle it. These status codes can be broken down into 5 different ranges. Okay. The first is 100 to 199 information response. The second is 200 to 299 success. Like the ones we saw in the example on the request and response, it was 200-0K success. Yes. Now 300 to 399 redirection, 400 to 499 clients errors. This is where it gets interesting, and 500 to 599 server errors. Now let's get back to this. Now, for the 100 to, that's for the information response, these are sent to tell the client the first part of their response or the first part of their request has been accepted, and they should continue sending the rest of their requests. These codes are no longer very common. Okay, so you will no longer use 100 to 199, I guess. So information response, more like, okay, you have this response, continue sending the request, something like that. Now 200 to 299 success, which shows the success. This range of status code is used to tell the client their request was successful. Great. Now 300 to 399, we have these, which are redirection. These are used to redirect the client's request to another resource. This can be either to a different web page or a different website altogether. All right. Now 400 to 499 client errors used to inform the client that there was an error with their request. And 500 to 599 server errors. This is reserved for errors happening on the server side. Usually indicates quite a major problem with the server handling the request. I think this is very important for web hacking or those who want to pen testing, I guess. Yeah. All right. Now let's see common HTTP status codes, and here we go. So now there are lots of different HTTP status codes, and that's not that's not including the fact that applications can even define their own. Yes, we'll go over the most common HTTP responses you're likely to come across. The first is the 200-0K. We saw that one. The request was completely this request was completely successful. That's what it's created. Now 201-created is a resource has been created, for example a new user or a new blog post. Okay, 301 moved permanently. This redirects the client's browser to a new web page or tells server or search engines that the page has moved somewhere else and to look there instead. Now, 302 found similar to the above permanent redirect, but as the name suggests, there is only a temporal change and it may change again in the near future. Okay, 400 400 it means it's a bad request. This tells the browser that something was either wrong or missing in their request. This could sometimes be used if the web server resource that is being requested expected a certain parameter that the client didn't send. So bad request. Not authorized, 401, not authorized. You're not currently allowed to view this resource until you have authorized with the web application, most commonly with a username and a password. That's 401. Now 403, which is forbidden, you do not have permission to view this resource, whether you're logged in or not. And the 405 here says the method not allowed. This resource does not allow this method request. For example, you send a get request to the resource /create a account when it was expecting a post request instead. Now 404, this is very popular, page not found. This page or resource you requested does not exist. Now 500, internal service error. This is related to the web server. The server has encountered some kind of error with your request that it doesn't know how to handle properly. Okay. Now 503, service unavailable. Now this server cannot handle your request as it's either overloaded or down for maintenance. Okay, now click the view side button on the right to see what some of these HTTP status messages look like in a browser. So 403 will be like, yes, I've seen this. 403, what's 403 again? It shows you do not have permission to view these resources, whether you're logged in or not. I've seen this before. Now 404, this is also very popular. The requested URL /missing.html was not found on this server, and it gives you some more information. And lastly, 503, service unavailable. The server is temporarily unable to service your request due to maintenance downtime or capacity problems. Please try again later. And this is more like the 503 error message. Okay, now let's answer the questions here. What response code might you receive if you've created a new user or blog post? I think that is 201. Correct. Now, what response code might you receive if you've tried to access a page that doesn't exist? That should be the 404. Popular. Great. What response code might you receive if the web server cannot access its database and the application crashes? Is that not the 503? We just saw that here right now. Okay, what response code might you receive if you try to edit your profile without logging in first? That needs more like the 401. Correct. 401, you need more like a permission, not authorized. Great. Now we're done with tax 4. Let's head on to tax 5 here, the headers. Now, headers are additional bytes or bits of data you can send to the web server when making requests. Now, although no headers are strictly required when making a HTTP request, you will find it difficult to view a website properly. Okay, now common requests headers. Now, these are headers that are sent from the client, usually your browser, to the server. First is the host. Some web servers host multiple websites. So by providing the host headers, you can tell it which one you require. Otherwise, you will just receive the default website for the server. Makes sense. Now, the user agent. This is your browser software and version number. It tells the web server your browser software helps it format the website properly for your browser. And instead, if not, it will just give you some kind of random. It will not be organized, I guess. And so, and also some elements of HTML, JavaScript, and CSS are only available in certain browsers. Okay, so your user agent header sent to the web server is very important. Now, content length. Now, when sending a data to a web server, such as in a form, the content length tells the web server how much data to expect in the web request. This way, the server can ensure it isn't missing any data. Very important. Now, accept encoding tells the web server what types of compression methods the browser supports, so the data can be made smaller for transmitting over the internet. Lastly, cookie, very important. Data sent to the server to help remember your information. See cookie tags for more information. We'll get there, I guess. Now, common response headers. This is the common request headers. Now, the response headers, these are the headers that are returned to the client from the server after a request. Set cookie, the information to store which gets sent back. Information to store which gets sent back to the web server on each request. See cookie stacks for more information. We're getting there. Cache control, how long to store the content of the response in the browser's cache before it requests it again. Alright, now the content type. This tells the client what type of data is being returned. That is HTML, CSS, JavaScript, image. I think you can see here more like some of the information that usually returned, maybe from an error or a common response header, I guess. That's just part of it. Using HTML, CSS, JavaScript, images, PDF, video, etc. Using let me see, for error. I think that was for 3. Doesn't have it. I thought I saw something. Okay, I don't have that. Now, sorry, let's continue. Using the content type header, the browser then knows how to process the data. Okay, now content encoding also returns. It comes from the response header. Now, what method has been used to compress the data to make it smaller when sending it over the internet? Okay, now what header tells the web server what browser is being used? I think that's the user agent. Correct. What header tells the browser what type of data is being returned? What type of data is being returned? Is that content type? I think this content type. Correct. Now, what header tells the web server which website is being requested? Is that not host? Yes, host. It's a request header. Okay. Great. Now we're done with tax 5. Let's head on to tax 6, cookies. You've probably heard of cookies before. They are just a small piece of data that is stored on your computer. Cookies are saved when you receive a set cookie header from a web server, just like what we just treated. Then every further request you make, you will send the cookie data back to the web server. Because HTTP is a stateless, doesn't keep track of your previous requests. Now, so cookies can be used to remind the web server who you are. Some personal settings for the website, or whether you've been to the website before. Now, let's take a look at this as an example of HTTP request. Now, you send a get request, host cookies .thm user agent SSS. Now, this client requests the web page from HTTP from cookies.thm. Now, the server responds back with a simple page with a form asking for the user's name. This is the success. This is the server details, dates, just normal content type, and then HTML data. Now, the client sends back the form with the name set to Adam. Name Adam. Okay, that's the sending back. Okay. Now, the server responds with the set cookie header telling the client to save the data name equals to Adam. Set cookie. Now, this is what we're looking at here. Set cookie. And on the next and every further request the client sends, the cookie data sends the cookie data back back to the server. So it will always have the cookie name is Adam, just to remind it it's you coming back. Now the server then sees the cookie data, and instead of displaying the form, it displayed a welcome back message instead. Welcome back. Okay. Now cookies can be used for many purposes, but are mostly commonly used for website authentication. Now the cookie value won't usually be a clear text string where you can see the password, but a token, unique secret code that isn't easily humanly guessable. Now, viewing your cookie, you can easily view that what cookies your browser is sending to your website by using the developers tool in your browser. And if you're not sure how to get to the developers tool in your browser, click on the view site button at the top. We've done that of the text for a how-to guide. Now, once you have developers tool open, click on the network tab. This tab will show you a list of all the resources your browser has requested. You can click on each one to receive a detailed breakdown of the request and response. If your browser sent a cookie, you will see this on the cookies tab of the request. Alright, now which header is used to save cookies to your computer? That should be get cookie. No, that should be set cookie. Sorry, not get cookie. Sorry about that. Cookies. What am I not spelling correctly? Set cookie, not underscore. Set cookie, that should go now. Perfect. We're just looking over here. We just basically, if you right click, you go to inspect, or there are different options you can use. More tools, web developer. Once you open this, it will just give you more like, should I say view page source? Not this. It's basically inspect. Yes, over here. Sorry, it's very tiny. Let's see. And then we go to network. I'm not sure it's here. Let me see. Yes, network. Once you click on network, should be able to get an option for. Yes, exactly. So this is it. So on network, we can get an option for the cookie here somewhere. Where is it? You know what? We can try this some other time. But yes. So let's go over to the last task here. So the last task here is making requests. Now click the view site button on the right. This is an emulator for making demo HTTP requests using what you've learned from the above tasks. You can use it to complete the below requests. Okay, finally it's booted up after a couple of minutes. I keep getting this, I don't know why. Alright, now making requests, like we said, we have to click the view site. We've done that now. This is an emulator for making demo HTTP requests using what we have learned from the above tasks. You can use it to complete the below questions. Now let's get to it. Here it shows to change your HTTP request method, to change the URL here, update your get and post parameters here, and then click here to send your request. Alright, all that noted, so we're ready. Now make a get request to /room. Get request / all I need to just put here is room, and I'm going to hit go, and of course we got a response. We see success and all that, and then we also have our code here. So we have that. Submit. Now make a get request to /blog, and using the gear icon set the ID parameter to 1 in the URL field. So we're looking at /blog, and we're setting the key here is ID, and we're setting it to 1, and then we'll save that. Once we do, we'll go, and of course that went. So you can see success the blog, and then here we go with the code or the flag. We got the flag here. Now make a delete request to /user/1. So we're going to delete, and we're going to delete /user, /1. Okay, and now we'll hit go, and the user has been deleted. We got that successful. So Tryhackme flag here, deleted. Great. Now make a put request to user /user/2 with the user parameter set to admin. User parameter set to admin. Username parameter set to admin. Okay, so we're using put, and we're using this to user2, and the parameter we can just delete this, and here we're using username. Yes, username, set it to admin. We save and we go. So username changed to admin, and we'll have the flag. Okay, there is T right there. Paste and we go. Perfect. Now I'll post the username of the THM and a password of let me in to /login. So we're going to make a post here, and sorry, we're going to log in and we set the parameter first. Let's delete this one first. We have the username. Username is the THM. Save that, and then we have password. That's too much. Password. What's going on? Password. We set that to let me in. Save that, and then we'll have all our parameter, and then we hit go, and you logged in. Welcome back. Tryhackme flag here, completed, and there we go. That's the end of the room. We've completed this room here on HTTP in detail. Thank you for studying with me. I'll see you guys in the next video for how websites work. Yes. Thank you again for learning with me, and have a lovely day. Ciao.